Let's be honest. When you hear the word teleportation, your mind probably jumps straight to sci-fi heroes beaming across the galaxy. But what if I told you that teleportation is real? That it's happening right now, and that it's something way, way stranger and maybe even more powerful than you've ever imagined? All right, let's get into it. And look, this isn't just some far-off theory anymore. This headline is talking about a massive breakthrough that has scientists buzzing. Why? Because it proves quantum teleportation can work over the very same internet we use every single day. What was once pure science fiction is now, officially, becoming scientific fact. Okay, so first things first, we've got to separate the Hollywood version from the incredible physics that's actually going on here. Yeah, we all know this one, right? Beam me up, Scotty. It's the first thing anyone thinks of when they hear teleportation. You know, the idea of deconstructing a person here and perfectly reassembling them somewhere else. But here is the single most important thing to get. Real-world quantum teleportation isn't about moving matter. It's about transferring information, specifically the quantum state of a particle. You can think of it like its unique digital fingerprint, its precise identity, and then beaming that from one place to another, instantly. And just to put that whole sci-fi dream into perspective, take a look at this number. That's roughly how many atoms are in a single human body. The amount of information and energy it would take to scan and reassemble all that is just staggering. One scientist said it would take more energy than exists in an entire galaxy of stars. So yeah, for now we're sticking to information. Much more manageable. So you're probably asking, how on earth can you transfer information instantly? Well, it all comes down to one of the absolute weirdest and most wonderful ideas in all of physics. It's called quantum entanglement, and it is so bizarre that Albert Einstein himself famously called it spooky action at a distance. Imagine you have two particles that are linked in this special way. You can separate them by a mile or by a whole galaxy. It doesn't matter. The moment you measure one of them, you instantly know the state of the other. It's like they're communicating faster than the speed of light. I know that sounds impossible, so here's a great way to think about it. Imagine you and a friend each take one shoe from a pair, but you don't look at which one you have. Then your friend flies to the other side of the planet. The second you open your hand and see you're holding the left shoe, what do you know? You instantly know your friend has the right one. No information was sent, but you gained that knowledge instantly. That's kind of how entangled particles are linked. Okay, so knowing the theory is one thing, but making it work in the real world, especially the messy, noisy, crowded world of our actual internet, that's a whole different challenge. And that's where this huge breakthrough comes in. This analogy just nails the problem scientists were facing. See, quantum states are incredibly fragile. A quantum message might just be a single particle of light, one photon. Now imagine trying to send that one tiny fragile photon down a fiber optic cable that's already packed with billions of other light particles from everyone else's internet traffic. People thought it was impossible. But a team led by Professor Prem Kumar at Northwestern University found this really clever workaround. Instead of trying to clear the entire information highway, they basically found a quiet, little-used lane. They tuned their quantum signal to a specific wavelength of light where there's less traffic. And then they just added special filters to clean out any remaining noise. It's just a brilliant way to protect that fragile quantum message. And the results were just stunning. They sent a quantum state through 30 kilometers of busy fiber optic cable. You can see it right here in the chart. Before their solution, the quality of the information was really low, but with their fix, the quality shot right up. It proved that quantum data and regular old internet data can actually coexist on the very same lines. And this right here is the game changer. It means we don't need to build a whole new internet from scratch. We can use the trillions of dollars of fiber optic cable that's already wrapped around the globe. This brings that quantum future much, much closer to today. So why does all this matter? I mean, what can we actually do with it? Well, this breakthrough could be the foundation for a completely new technological world. The applications are just staggering. We're talking about a quantum internet that would allow for perfectly secure communication. If anyone tried to eavesdrop, they'd be instantly detected. It could lead to sensors with just unimaginable precision. But maybe the biggest application of all is in the world of quantum computing. So here's the problem with quantum computers. To be truly revolutionary, they need millions of quantum bits, or qubits. But trying to pack that many into one stable machine is an immense engineering challenge. The more qubits you add, the more unstable and fragile the whole thing becomes. So how do you get around that problem? Well, this quote from a researcher at Oxford points to an incredible solution. Instead of building one giant, unstable machine, what if you could just wire together a bunch of smaller, more stable quantum computers and make them all act as one single, powerful brain? And that is exactly what quantum teleportation allows. It's the wire. It's the invisible connection that can transfer quantum information between these separate modules instantly. This lets us create a single, distributed quantum computer that's far more powerful and scalable than anything we could build in just one place. So while we won't be beaming ourselves across the galaxy anytime soon, quantum teleportation lets us move information in a way that just defies distance, creating connections at the most fundamental level of reality. And that leaves us with a pretty fascinating question to think about. If we can build an internet that moves information instantly, what new realities can we create?